This time we want to use a projection to find the distance between two parallel planes. So how do we know these planes are parallel? We have 2x plus 1y minus 4z equals 1, and 2x plus y minus 4z equals negative 9. So you'll notice they share the same normal vector. The normal vector is 2, 1, negative 4. Remember, the vector doesn't exist in space. It just tells us the direction. Move 2 units in the x direction, 1 unit in the y direction, and 4 units in the z direction. So let's consider what this looks like in essence. We have two parallel planes, and they share a normal vector. So for the sake of discussion, let's call that the normal vector. So how do you think we could figure out that distance, the shortest distance between the two parallel planes? Again, the tool we want to use is a projection to get there. So what are we going to project onto that normal vector to find that distance? That, in essence, is our question. So here we can see the two planes that we put together using Desmos. 2x plus y minus 4z is 1, and 2x plus y minus 4z is negative 9. And the question is, what is the distance? Now, if we would just go down the z-axis, that is not the shortest distance. We need to think about what that shortest distance would be. Well, I've actually gone ahead and constructed a line that represents the normal vector. So notice this green line is some multiple of the normal vector. We're looking for that portion of the normal vector that is between the two planes. We want to project something onto that normal vector. So if we assume it starts here and goes that way, if we project something onto that normal vector, we can get the distance between the planes. But then the question is, what are we going to project onto that vector to find that distance? That's what we need to think about. So if we come back here, we see the normal vector here. So let's think of this giant thing as the normal vector. But the distance between them, right, it's going to be this portion. So that is going to be the distance between them. Again, this is not the same slantiness as we saw on Desmos, but you get the idea. So what am I going to project onto that normal vector to find the distance between the two planes? What is my strategy going to be? Well, I'm going to pick a point on each plane. Pick a point on each plane. If I pick a point P up here, and pick a point Q down here, and I construct a vector PQ or QP, and then if I project it onto the normal vector, that will give me the distance between the two planes. So how about a point P on the top plane, based on how I've got it drawn here? So if I have 2x plus y minus 4z equals 1, do we see an obvious choice for P? Is there a simpler one than others? What's a point that is on this plane? How about 0, 1, 0? 2 times 0 plus 1 minus 4 times 0 is 1. So that's my point P. How about Q on the second plane? The point Q has got to be on what? 2x plus y minus 4z equals negative 9, going for the same idea. If x is 0 and z is 0, y would have to be equal to negative 9. So Q would be 0, negative 9, 0. So if I'm thinking about vector QP, starting at Q, ending at P, what is vector QP? What is vector QP going to be? QP will be from 0 to 0, the change in x is 0. From negative 9 to 1, that is up 10. And from 0 to 0 is 0. So that's my vector for QP. And I need to project QP onto n. We see this? This vector here is the projection of QP onto n. Projection of QP onto n. The magnitude of that vector will be the distance between the two planes. Now, what is n? What does n look like? N is the vector 2, 1, negative 4. And how do I get the projection of QP onto N? What will that be? Projection of QP onto N is QP dot N over N dot N times the vector N. So QP dot N over N dot N times the vector N is that projection. So what is QP dot N? What is that going to give me? 0 times 2 is 0, plus 10 times 1 is 10, plus 0 times -4 is 0. Over N dot N, which is going to give me what? N dot N is going to be 2 times 2, which is 4. Plus 1 times 1, which is 1. Plus -4 times -4, which is 16 times N. So what do we get here? We get 10 over 21 times the N vector is the projection of QP onto N. And again, we know that the magnitude of that is going to be the distance between the two parallel planes. So we're going to say distance equals the magnitude of the projection of QP onto N, which is the magnitude of 10 over 21 times N, which is the absolute value of 10 over 21. 10 over 21 times the magnitude of N. Now let's remember what N was. N was 2, 1, -4. What did we say N dot N was? We said N dot N was 21. We said that before. So the magnitude of N is the square root of N dot N, which is the square root of 21. So we get our distance between those two parallel planes is 10 over 21 times root 21. And if you want to, you can rationalize the numerator and say that's the same thing as 10 over root 21 would be the distance between those two parallel planes.